Hello again. Today we are going to learn more about the LED matrix program. If you have seen my previous video, which was based on the Freenove kit, and which looks like this one, and I explained in quite a detail that how these LED matrices work, and it's already fixed in this development board, so I don't have to wire everything up, but like the logic is same. And if you use this similar thing and have the same circuitry, you would find this video or this video in general very helpful. Okay, so I would put the link on the top here and also in the description if you want to have a look on that. So I just wanted to make the previous video more useful by extending it to the next level. Okay, so just a little bit. In previous video, we had uh, we had this data array, in which we had this data, and that this data represents the numbers, the patterns. So 1, 2, 3, 4, 5, 6, like this, A, B, C, D, up to F. Okay, so it's not a full ABC. The first thing I wanted to do was to extend this data frame, this data array, to a full ABC, so that I can write my whole message using any letters. Okay, so that's the first thing to do. And when I have that, I will just write a message, and that message will be shown on the LED matrix display like this one. Okay, so just it's a previous in the previous video that how would you make a pattern onto these LEDs. Okay, so these are the columns and these are the rows, these are the columns. We just have to fill in the ones and zeros. The ones are for the LEDs which are on, zeros are for the LEDs which are off. Okay, so I've made this whole document. Actually I had to work a lot in on this because of the addressing of the rows and columns. You would want to do this actually. So here we have the data up to F, but for F in the letters after F, you have to make their own. Okay, so like FG, we have the letter G here, and you can see that 1 1 1 like this one, and this is the MSB of the column, and this is the MS, MSB of the row, sorry, here, and like this, and this is the MSB of the column. Okay, so we are just scanning the row one by one, as it will be described in the code here. Okay, again I would say, if you want to learn about the full working of the LED matrix, please go to the previous video. So here's the scanning and going through. So okay, so technically we only want to write the values for the columns starting from this top to here. So MSB and LSB. So if you can see G, all, and there are no LEDs on here. Each box shows an LED. We have all zeros. We have 2 boxes 0, 4 boxes 1, like this and like this one. So in this way, this is the G written differently. You can see that only one column is left blank, and but when I printed it, like when I put it on the display, it didn't quite seem well and in fitting with the rest of the characters, alphabets. Okay, so I just had to leave the 2 columns blank, so you can see that the data is different accordingly here. Okay, and you just, this is column 1, and this is column 2 here, this is column 3 here, this is column 4 here, this is column 5, and this is column 8, which is up to here. Okay, and this is the way you write the data in the binary. And here the data is in the hex, so 0x means it's a hex data. But if you want to write it in the binary, you would write it in the binary. Okay, so I'll just close this one because it's the old code, and this is our new code here. Okay, so the binary data is over here. We put a comma, and then for the G I have this data for all the 8 columns: 1 2 3 4 5 6 7 and 8. I have all the characters here, and including a few punctuation symbols here, like the period, comma, exclamation mark, and the question mark. Okay, I've made everything in here, like the H here, the I and J and SAR, and what's the data that is to be made with the columns in here, up to M N O P Q R S T U V W and X and Y and Z, and this is the question mark, like going like this. So you can have an idea that you can pretty much make any pattern that you want by making the LEDs 1 and 0. Okay, okay, so let me show you, first of all, let me show you the working of the code, and then I'll show you how this code works. Okay, so first of all, I have this, and I'll be writing, I'll be testing all the characters over here from A, B, C, D, E, F, G. We have the space character as well, the space in here, and we have the period, we have the comma, we have the question mark, and we have the exclamation mark. Okay, so we will test all these. So there are just, if you want to use this code as is, you just want to do two things. First, define your message in capital letters, and number two is you have to fill in this thing. How many characters are there in this short message? Okay, so ABC is like a 26, 7, 8, 9, and 10. 26, 7, 28, 29, and 30. Okay, so we have 30 characters over here. You don't have to mess up anything else. Okay, so you can see A, B, C, D, E, F, G, H, I, Q. You saw that the X was a little bit bigger than the others. Okay, so I still can use these potentiometers to show you the scanning, the columns and rows. You can see if I slow down the scanning time of the LEDs, you can see that yeah, so this is how the actual column scanning happens. Okay, you can barely see the pattern, but when it is done fast, you would see that there's a special character. Yeah, I'll just turn it to normal, and you can also set the speed of the scrolling. This is now slow, this is fast. Okay, so that's how it should work. Now coming back to the code, so how does this work? Okay, so this works by first by finding out what's in this string. Okay, so first of all, the reason behind putting this whole data using this program mem function is that it goes into the flash memory, not into the RAM. Okay, because the RAM is very much limited onto the microcontroller, so this is written onto the flash. So we just have to give the address of the flash memory and the program will automatically read the data from it, because this data is only fixed, written once. Okay, we don't want to make any changes to this data, so there's no point that this should be in the RAM. Okay, and so what happens is that each of this character has an address in the ROM, you would say, or flash memory. Okay, and that and that that thing that thing would be addressed by the index of this data over here. So if I say data 0 here, I mean that I am referring to this part of the data. Okay, so I know this and the arrays in the C programming start from the 0. Okay, so 0, if I say 7, it means that this is the 8th data over here. Okay, and yeah, if I say 8, and this would mean that I'm pointing out to this one. Okay, so likewise this one. So in this way we do the calculations, and we can refer to any data part right here, and that's what I am using to find out what character is being addressed in this short message. Okay, with that being said, uh, and now I will go to this function, which is search index, data index. Okay, so I have made this just to find out what characters are in this string. Okay, so short message, that's the array that holds this data, and in this data we have this function search array index, and it takes in this short message. Okay, and in this short message we have something like this. Okay, we have the character position, we have a for loop technically, and first of all it scans for this space, and then yeah, it displays the array index, update the display array, and it's 0 0. Update the display array plus plus, and the character position found plus plus. Okay, so this means that skip the first character or whatever, and the if statement matches into the any character in the short message, that would be the first. Okay, that first if statement will be triggered. So that means that we have identified the first character into the display message in this short message. Okay, so in case we have double letters like AA or BB or CC, so and this will also take care of that one. It will not repeatedly stuck in this same character. Okay, so that's why this is here, character position found. So the KK will start from this point. Okay, every time a character is found, we will start from an increment. And we have to update the display array, which is this one, display array. This display array is another global array in here that holds in the indices of the whatever we find the short message. Okay, whatever character we find in here, we find the index of that character, the first one, into this whole array, and then yeah, just the first index. And the remaining eight bytes, if we just have the starting point, the remaining 8 bytes will be read by the loop which is coming ahead. Okay, so we update that the character array. So the display in array index only stores the first value of the starting point of any of these characters which are found into the short message. Okay, so if you come in short message KK, which is from this for loop, whatever wherever it matches, it will just update the array index array, update the character position, and update the display array. Okay, so in this way we compare all the letters, we run the loop through, and including the special characters that we have in here, like the question mark, like the exclamation mark, and the comma. Okay, so this is how you find the characters in your message. Okay, the length will run until this point. That's why we need to update these two things: the short message and the number of characters in the message. The number of the characters in message will run the for loop up to that point. If I run the for loop for lesser, it will cut the string in the half, or maybe whatever the size you would write in there. If you put more, like if there are 30 characters in here, if you put more, it will just put the random data over there, or whatever is found in the flash memory and at that point, or it will just put in the spaces. Okay, and then we have another global variable, a global array, that is the data display data array 8. Okay, so yeah, okay, so the rest of the point, the program is just similar as in the previous video, and in the white setup we run once the display array. What it does, it takes in the short message, this array, and fills in this display array, fills in the indices of the characters which exist in the short message. Okay, yeah, cool. So then we just run the loop, and in the loop we have some tricky things going on. Okay, so yeah, we have again we have a for loop, and the for loop runs until this point, up to this point, which is the number of characters in the message. Okay, so these are 20, so we saw that we had the whole of ABC and 4 of the punctuation marks. Okay, so what's happening in this for loop is this one. You just update the display array data. Okay, you remember you have two different arrays. One is display array data, and other one is the display array index. The display array index just points to the initial data byte of that character in this array. Okay, and then this loop, the inner for loop, you can see that read 8 bytes, starts from that index and loops through all the 8 bytes. It starts, let's say it's letter Q, so it starts from this point and it loops through all the 8 bytes here. Okay, so now you're getting closer, I think, because there is no need to store the whole thing into the display array. Okay, so display array, just the first one. Okay, and that's a very tricky part. Okay, you can see that we just have to update only the first element of the display data array. Okay, and using this one, and the character counter is here, the character counter, and plus the read 8 bytes, because okay, so here the read 8 bytes will help run through all the 8 bits, 8 bytes of that character. Display array index that holds the index of each letter, which is found in the display in the short message, and yeah, and that would give together all this. It will, and there are only two variables, right? The character count. So character count is 0. That means that if it's ABC, it points to the first character in the short message, so character number 0. and the character number 0 consists of the 8 bytes, like the 8 columns. Okay, so 0 plus all the 8 bytes with this loop. Then after this we have the other one, character number 2, which in this string is B. Okay, so the character count in the index, we will point to the first index of the B and then read all the 8 bytes. Then it will update character number 2, which is here C, and what will happen that it will point the first character and loop through all the 8 bytes like this one. But the catch is all the things go into the first byte in here. So where are the all the other bytes? Because we know that the display array consists of the 8 columns. Okay, so yeah, before I proceed, I just want to have a look on this thing. This is a special function which calls in the ampersand sign. This is the method you read the flash data from the Arduino. Okay, so on this data is the array over here. Yeah, in here, and this is the function of the Arduino to read the way to reach the flash memory. Okay, so again, back to the point. We just update the first element in here. Okay, so we just update the first element, and then we do this refresh display. Now this refresh display is here. Okay, what happened? The refresh display function actually it updates and helps us to scroll the data, and which in turn scrolls the display. Okay, the reason you see the characters moving is because of this function. Okay, you can skip the this one because the analog read over here, this is what we use to use the potentiometers to set the speed of the scrolling and the speed of the scanning. Okay, you can use the fixed numbers as well in here. Okay, so we have this first loop for, okay, and similar thing, we start the column and we send this display array data, which is here, display array data, which this is what is shown or what will be shown onto the display matrix. Okay, this array is whatever is on this array, it will be shown onto the display matrix. So that's what you have to remember. So first thing is this matrix, and we have to do this display J, and J is here. Okay, and the columns is here. We shift the bit to do the column scanning, and the speed of the column scanning is set by potentiometer 2. Okay, so yeah, and the time it will keep on scanning all these columns again and again and again, will depend on this h. Okay, so the quicker this loop runs, the quicker letters scroll. Slower this loop runs, the slower this loop or the display will scroll. Okay, so once it's done this whole loop, okay, for whatever this value of hh is, it shifts the data. It shifts the data in from within the display array. Okay, so display array data in here. So this is a negative loop. What happens if it starts from 7 and goes until the 0? What happens? The data that we load in 0 goes forward to the next indices. Like the data from the 0 goes to the 1, the data from 1 goes to the 2, data from 2 goes to the 3, data from 3 goes to the 4, and goes like that. And it's very important that the data exchange must start from the 7. Okay, because if you started from 0 like a positive loop, all the other data will be just scrambled or gone. Okay, because we are only updating the first element in the display array data. We want to save all the data which is from the 6 to 7. The seventh yeah, the element number 7 in the display array, and that data will be gone. Okay, because there are only 8 elements. So 7, the data for the 7th element will be gone. Data from the 6th will be coming into the 7, from 5th into the 6th, from 4th into the 5, and element number 3 will be coming into the 4, element number 2 will be coming into 3, element number 1 into 2, and element number 0 will be into the 1. Now you can realize that if we do that and then just try to display this data, whatever in here it is in here, it will automatically scroll. Okay, so this matrix is the function which sends out the data to the shift registers. It is just here and uses the data pin and the clock pin. The description of these is also available on the previous video. So yeah, I just made this these changes to the program, and most of it I've written myself, and just to help us out to display a quick message, a full complete message, unlike the previous video which just uh, showed the basics of how the LED matrices work. Okay, so let me comment this one and uncomment this one. Okay, so as I said, the method to use this program is to write whatever message you want and then count the characters. Okay, like this is exclamation mark. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So you have to include the spaces as well. So we have 20 characters including the spaces. Okay, so here we have the program. You can see that write your message here. Okay, and the exclamation mark as well. So yeah, that's it. And after all, let me write the name of my channel. That's pretty amazing. You can see that the program doesn't show the double the columns. Okay, because that is not present in this data array. Amazing. So it just automatically picks up the letters from the data array. Okay, and whatever, if you made this form, I will just say please do subscribe. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's close. Only the same number, 20. Amazing. So it just automatically picks up the letters from the data array. And yeah, please subscribe to support this channel. And yeah, if you have any questions or comments, do discuss it in the comments section. I will put this this document into the GitHub. Actually, I've already put it. Yeah, if you go to the GitHub, you would find this one. This is my GitHub repo. I have just started using it, and this is the LED matrix, this is the code, and you can play with it and make any modifications as you like.